So by the looks of it, the Samsung phone charger got a little hot. I took this away from a friend who was having trouble using it, and I can see why. It seems to have had problems. So let's do a little teardown and see if we can see anything obvious that happened to it, or maybe it just got too hot from over drying and there's no protection in it. So let's crack it open. The tiny chisels hiding. Well, that produced no results. Alright, all I did was stick this on the floor, chisel at an angle, and it popped off. It has been sealed, and there's also 2 little clips. And this just comes right out. There's little... Ooh, that smells bad. There's little places to accept the connector, little edgy type connector at the bottom. So if that went in like that... I really don't know why that pin would get hot internally. Well, I can't tell for certain, but there might have used to be a little component there that exploded. Maybe. Some of these marks are whatever this pen is. Interesting enough, I actually marked out the year on here. I don't know why. Seems to just be solder across it, 'cause I cleaned it off with some little Q-tip and alcohol-y stuff. It doesn't look like it's a component. Not my stuff on that anymore. So, but as far as I can tell, this is a true OEM Samsung, because the RF tech and the design. But the whole board kind of smells weird, but you know, maybe that's just the manufacturing. Overall, it is a really nice design either way. They have this incredible isolation boundary that even wraps around the capacitor for some reason, and then goes all the way through. Clearance and creepage is perfect because there's this plastic blockage in the way. Nothing can happen. So this is an incredible amount of isolation. Really safe, I would say. I can't be for certain what happened to this. It might have even been outside things like intense electrical noise on the wall socket or something like that caused it. Bad wire, faulty house wiring somewhere, or too great of a load. Maybe it doesn't compensate for that. I don't know. I'd have to get a identical. I can't quite read the model number on the unit, but I'd have to get an identical charger and compare. If you notice, they have it's a pretty impressive spark gap. I mean, to jump that, how much would you need? It's close. So about 5 millimeters. You can sort of see the path it takes. This is the bridge rectifier. It goes immediately to this capacitor. And then I'm assuming that tells you it's jumping through a presumably fusible resistor or something, or an actual fuse, to link over to here, which goes through that this capacitor here. And that goes into this side of the transformer. And this mess, I'm trying to see how it's... Yeah, as far as I can tell, this goes all the way across. Massive amount of solder here for current handling and the likes into the other pin of the transformer. Here's their different windings. They go into a complicated mess with the control chip. Hops on over to the secondary side where they do a little bit of touch up to it. This, I believe, is the filtering cap for it, 470 microfarad at 10 volts maybe. It looks like 10 volts. Here's the giant sticks for holding on the USB connector. So we can see they directly bridge the data connections on the USB connector to tell it. Pretty certain that just tells it it's a regular, I think, fast charge or something like that, but can't quite tell if that trace actually goes somewhere underneath or goes directly into this bar, but I'm wondering if this is the discharge resistor for the main filter caps. But overall, it's a nice design. Through-hole style. You can tell it's not surface mount done. There's the glue underneath each of the surface mount components. The little red is the dots of glue they would put down to stick the components until they actually wave soldered this. Even the I mean, they cared about quality. Even the transformer has a mark on it, hopefully telling that it's good and not bad. And then this is an entirely bad unit. And then if you wanted to attempt to see it, here is the actual label for everything. Again, that's the wiggly joint. You can look down there. So this is the bad side. This is a non-universal plug type to where they have to change out the casing in order to change the actual plug, whereas some have a release and so on. But I'm pretty sure this would be just the identical same board everywhere. And you would just drop it in the casing of your choice for what country this is designed to ship to. Look, it's got a model number. Whoever G Luxon is, and I don't know who that is. Capex something. Capexon. Well, it's too bad we couldn't come to a conclusion. Really nice. They even have slides on the side to where this slots in and goes right where it's supposed to. And you just click it down. There you go. It's installed. Alright, we gotta try powering it on, testing it. Slide that in there. Put the cap back on for safety. Perfect. Now I just gotta go grab a power strip. Alright, here's our test setup. I'm about to flip the switch and we'll see if anything happens. Nothing. Take two. This grips a little better. Nothing. I don't know. This just doesn't work now because I guess this doesn't make contact. So let's try pushing it out. It's there. Okay. And continuity. Now we can test the power supply for certain. Same test as before, slightly messier, slightly more precarious. And it charges. Alright, now let's try turning on the charger. And does this not tell me the rate at which it charges? Oh well, you get the point. So in conclusion, yep, we fixed it. It doesn't necessarily mean that it is safe, but the other problem was that if you have a pin that's too recessed, it won't make good contact, and it doesn't work. But yeah, I wouldn't recommend continuing to use something that had that happen, or trying to figure out if your house wiring and everything is okay. There, I've fixed it. Hit subscribe and like this video, share, comment, all of those things, express your opinions. Do it, come on, it's fun, enjoy.